Hi everyone, this is Mr. Zikri. In this episode, we are going to study about liquid pressure. There are several questions that we would like to answer. First, what is liquid pressure? And what does the liquid pressure depends upon? And then, how do we calculate the pressure at a point inside the water? As you can see here, we have a container filled with water, and that water having density of rho and depth of h and the base area of A. We would like to find the pressure at the base by using solid pressure concept. So the pressure at the base basically is the force given to the base divided by area. The force itself is the weight of liquid. The weight of liquid over area. The weight of liquid is mass times gravitational acceleration, and because we know that density is mass over volume, so mass equal to volume times density. So this mass can be substituted by volume times density. Well, volume itself is actually base area times the height. So the volume can be substituted with area and h. Let's cancel area, and what do we get here is liquid pressure at the bottom of this container equal to depth of the water, density, and gravitational acceleration, which is 10 meter per second squared. And as you can see here, there is no area variable, so it doesn't depend on area. It only depends on the depth, density of the liquid, and the gravitational acceleration. Here there is several quantity that you have to memorize very well. The density of the water is 1000 in kilogram per meter cubic, while in gram per centimeter cubic it's 1. And there is another substance that we have to remember very well. The density of mercury, 13,600 kilogram per meter cubic, and in gram per centimeter cubic it is 13.6. Example: what is the pressure on a person when he is swimming at the bottom of a pool that is 5 meter deep? The information from this question only the depth of the swimmer, but another variable is actually should be memorized, and we have to recall it very well. So from the information given, h is 5 meter. The density of the water is, as we know, 1000 kilogram per meter cubic, and the gravitational acceleration is 10 meter per second squared. So to find the pressure on the swimmer, we can calculate by PHDG as h 5 meter, density 1000, and gravitational acceleration 10. So we have here 50,000 Pascal. Or if we want to write it down in scientific notation, we can write it down as 5 times 10 to the power of 4 Newton per meter squared. So you can use Pascal or Newton per meter square as you wish. Next question. Here we have a block that is immersed inside the water. There is point 1, 2, 3, and 4. Which one of the following shows the correct order of pressures acting on the box inside the water? So if we want to know the pressure at 1, 2, 3, and 4, we have to measure the depth from the water surface. This is H1, H2, and 4, and this is H3. Let it write together. Let us write it down. H1, H2, and H3. As we know, the pressure, liquid pressure, depends on the depth, density, and gravitational acceleration. While the density of the water for point A, for 4.1, 2, 3, and 4 are the same, and gravitational acceleration also staying the same. So it's only depending on the depth. So let's write it down from the biggest one to the smallest one. H3 bigger than H2 equal to H4 bigger than H1. Therefore, the pressure will follow as this one. The answer is B. Next question. There is 3 containers A, B, C having liquid A with density of D, 2D, and half D. And the height or the depth of H, 2H, and 2H. What is the relationship between the liquid pressures at the bottom of the containers? So let's calculate one by one. For A, the height is only H, density D, and gravitational acceleration G. For the second container, the height 2H and the density 2D times G. So PV 4HDG. The last one, PC 2H D over 2 times G. Let's cancel this one, and we have HDG. So the pressure at the bottom here for A and C are same, for B bigger than both of them. So let's answer it. The answer is C. Next, this one is classwork. So you can write it down and answer it on your notebook. Okay guys, that's all for today. That's all for this episode. I hope you enjoy this video. I hope you learn something from this, and see you next time. Bye bye.